Oh, that fish?
What?
What speaker?
We'll see after our notes. Yes, I got hungry.
Mr. Duros, are you a video game designer?
I am not.
Do you play video games?
I used to play more, but I haven't played in a long
I
time.
mean modern games.
Yes,
Okay.
yes.
Okay.
Not just like Pac-Man
Okay,
from my
Pac-Man.
days of youth.
Do you play Minecraft?
No.
You should play that. That's
I don't have enough time to devote to that.
no, see, maybe
I don't want to learn all the recipes and mix this and that. All right.
I thought you were a science teacher.
I am, but I'm a business science teacher.
You should join my server.
Okay.
It has 80 pings. It's really nice.
All right. So, just to go over where we were yesterday. Yesterday we spent our class time just introducing concentration, solvent, and those sorts of things. And the reason we're doing that, really that's part of what you usually would cover in 8th grade, mixtures and solutions. But we need to know about it because concentration is an important factor when we start to talk about diffusion and osmosis, which is where we're going in this section. So, first off, we need to just remember about the cell membrane. So the cell membrane is a very thin layer. Okay? It surrounds the cell. And what did we say its main job is? Emma?
It allows things in and out of the
Yeah,
cell.
it is responsible for allowing certain things into the cell and not allowing others. Okay? We have a word for that. We say that the cell membrane is a semi-permeable membrane. Because we have some words that we use. When we're talking about a membrane, we could say that a membrane is impermeable to something. What do you think that means? Impermeable. Ooh.
Like, it can't get in.
Yeah, that it can't get through. Substance cannot pass through the membrane if the membrane is impermeable to it. So obviously, what does permeable mean? Nicole?
A substance can.
Yeah, that a substance can freely pass through the membrane. So the word we use for a cell membrane and most membranes is semi-permeable. What do you think semi-permeable would mean, Joey?
Lets some things in but keeps.
Yeah, there's certain things can pass through while others cannot. That's what a semi-permeable membrane is. And when we think about the cell membrane is the outer covering for the animal cell. And cell membrane is fairly complex. It's not just a simple, like, little thin balloon covering the outside of the cell. It's actually a two-layer. It's called a phospholipid bilayer. Okay, and you have the phosphorus heads on the outside of the membrane and on the inside. And then on the interior of the membrane are the lipids, a fatty substance. Okay. And then embedded or stuck within this membrane are various things, various types of proteins and other molecules. Okay? And some of these molecules act almost as a tunnel, allowing certain things to go right through the cell membrane. Okay? And so that's sort of what the cell membrane sort of looks like. Okay? And some molecules, so again, here's our membrane. This is the phospholipid bilayer. And some molecules can just sort of slide right through, past the membrane, and into the cell. Generally, those are very small molecules that are able to do that. Things like oxygen, water, carbon dioxide, they can very easily move through the membrane. Larger molecules are not able to do that, right? they're going to get into the cell, they need to get in through an alternate way, through one of these proteins or through some other method. Okay. So the cell membrane is an important barrier to certain things. All right, so let's just review here concentration. You think about what concentration is, it's the strength of a solution, or how much solute there is in a unit of solvent. And here, obviously, we have some Kool-Aid again. Kool-Aid of varying strengths. On this side, what kind of concentration of Kool-Aid powder do we have? Sasha?
Diluted.
Yeah, it's very dilute. So is there a high or low concentration of Kool-Aid? Low. Is there a high or low concentration of water?
High.
Correct. And then the opposite is true for the super dark, super sweet Kool-Aid on the right side. That has a very high concentration of Kool-Aid, but a lower concentration of water. And concentration becomes important when we start thinking about diffusion, about how molecules move. And so this word diffusion is very important, and you certainly need to know the definition of it. Okay? And diffusion has to do with molecules moving. Okay? So just to remind us, a molecule is basically the building block of matter. There are pieces of compounds, small pieces of compounds are molecules. And diffusion has to do with how those molecules move. In diffusion, molecules will move.
My paper wet.
Sorry, it's just an accident.
No, it wasn't.
Diffusion is the movement of molecules from an area of high concentration to an area of low concentration. Now, molecules don't really think. They're just pieces of matter. But if we think about it this way, we can say molecules don't like to be crowded. Okay? If they are in a crowded area, and they will tend to spread out evenly into an area where there's a lower concentration.
Like ice.
Okay? One example. If I make the analogy, I took every 7th grader in our school and I placed them in this classroom. Probably you could all fit. You'd all have to be standing and you'd be real tight. That would be a very high concentration of 7th graders. Okay? Nobody would be very happy. And then if I open up the door to the classroom next door, what would happen? You all would go there?
No.
Some would stay.
Some would go there, some would stay, and you would each have a little bit more space. And then if I open up the door to Miss Bean's room, again, you guys would spread out and get a little bit more space. So you would want to go from an area of high concentration to an area of lower concentration. A crowded area to a less crowded area. I wouldn't have to tell people, oh yeah, you go over there, you go over there. You would just do it on your own to get yourself some more space. We could sort of think about molecules doing the same sort of thing. The molecules don't want to be crowded. Okay? They wouldn't want to go to an area where there's a lower concentration. Some examples. Each morning, Mr. Arcuri comes in, and he comes in that back door, and when he puts on his perfume in the morning, he does it in that back corner. Okay? And so when he sprays that perfume, it starts off, the perfume molecules are in a crowded, tiny little area. But they spread out, and they start to spread out throughout the whole room. When I walk in the morning, I can smell it all the way in the opposite corner of the room, okay, because those perfume molecules have diffused throughout this whole room.
I feel like I smell.
So perfume diffusing through a room would be an example of the perfume molecules diffusing. If I place a drop of food coloring in this water, starts off the food coloring molecules are all crowded together in a small area. But over a period of time, they are going to evenly spread out throughout that water into the area of lower concentration. So that's diffusion, and the definition is just that, the movement of molecules from high to low concentration. It doesn't require any energy. You don't have to forcibly move the molecules to an area of lower concentration. They just do it on their own.
Mr. Duros?
Yes.
I wonder how you can remember this, but you don't want to remember the recipes for Minecraft. Just a random question.
All right. So, osmosis is. We're actually going to spend more time talking about osmosis than diffusion. And osmosis is just a special case of diffusion. So it works on the same principles. It's still molecules moving from higher to lower concentration, but it's a specific type of molecule. Osmosis is when it's water moving. When it's water moving from high to low concentration and it's moving through a semi-permeable membrane, that's what we call osmosis. The diffusion of water across a semi-permeable membrane. Still from high to low concentration, just like we talked about. But when it's water going across the membrane, we call it osmosis. And so we got to remember that in osmosis and diffusion, molecules will always move toward the lower concentration. So I'm going to draw this on this board here.
Yay.
So we have an apparatus we can use that demonstrates osmosis. We actually have it, but it's always leaks. So I'm not even going to bother setting it up today. But this is a YouTube. So we have this hollow tube, shaped like a YouTube. And it's split right down the middle. You could take the two halves apart. And what you can do is you can put a membrane between the two halves, separating this half from this half. Okay? A semi-permeable membrane.
Oh, okay.
Basically, it's a thin piece of plastic that has holes in it, microscopic holes, that allow small molecules to pass through, but not large molecules. All right, so we have our semi-permeable membrane here. And what you do is, in this U-tube, you put different solutions on each type. Let's say that these purple represent, let's call them starch molecules. All right. So if we look at, I put two different solutions here. Where is there a higher concentration of starch molecules? Nicholas?
This side.
Yeah, that would be the right. Yes.
This side.
There's a high concentration of starch over here. All right? And on this side,
Oh.
a lower concentration of starch. Okay, so what would the starch molecules, based on diffusion, what would they like to do? Bianca?
Some of them would like to go to the left side.
Yeah, they'd like to go from the right side to the left side and equal out the concentration. However, starch is a large molecule. It actually cannot get through that membrane. So even though it may want to move over here, it can't. So it's stuck. All right, so that's the starch is not going to do anything. Sorry, starch. All right, well, let's think about the water now. So the water that the starch is dissolved in. Where is there a higher concentration of water? Morgan? Yeah, here we have a high concentration of water. How about over here? Yeah, that's a lower concentration of water. All right, so what does the water want to do? Yeah, go from left to right. Go from high concentration to low concentration. And water molecules are small enough that they can pass through. And so water moves towards the lower concentration of water. And eventually what you see in this apparatus is that the water level on the right side rises. The water on the left side drops. And if you sort of eyeball it here, you can see the concentrations have equaled out basically. Okay? And that's because of this process. So what will we call this? Water diffusing through a semi-permeable membrane is called osmosis. So this is an example of osmosis happening. Herschel?
I forgot what Oh yeah. How do you know how big the molecules are? Molecules are.
You could measure them in various ways. You could tell whether or not if they go through the membrane, you know they're a certain size. If you know the pores in the membrane are, 200 nanometers, and the molecules don't go through, you know they must be larger than that. All right. Any other questions about osmosis? We're not going to get there. All right. You can put your notes away. Take out the egg sheet, please.
Yes.